This new method we messed with today
Wait, I'm on substitution.
is called elimination. And it is a method for solving systems of equations. That's our unit right now. Remember, when we're solving system of equations, we're trying to see where they cross, right? Keep that in mind the whole time. We're going to add or subtract to eliminate a variable. And I strongly suggest to start every problem, you do this. In your head you say, I will eliminate you. And it just makes it that much more fun. James? Okay. So these notes have like steps. You know me, I'm not into steps. We're going to approach these from a more like conceptual idea. Okay? So what other methods have we had so far? The first method we learned was what? Graphing, which is cool because it's a visual, right? This is what's happening. We've got these two lines crossing. It's not very accurate. Then we learned and substitutions based on the idea that x and y are the same at both spots. So x is x, y is y. You can put one in for the other. Today we're going to do the elimination method, which is all about eliminating a variable, just like with that warm-up, right? We got the same number of hot dogs, we could focus on burgers. Or if we got the same number of burgers, we could focus on hot dogs. Okay? Now, let me show you the simple math that this is based on, all right? So tell me if this statement I'm making is true. 6 plus 9 equals 15, and 6 minus 9 equals negative 3. Are those two statements true? No. Are you seeing that these are like kind of like standard form a little bit?
Yes.
Okay, because actually a times x is just a number. I just don't know one of the numbers, right? B times y is just a number. I just don't know the number. So watch what happens when I add these together. 6 plus 6, 12. 9 and negative 9, 15 and negative 3. So it appears as though if they're both true and there's something that cancels or is the same, it makes a new equation that's true, right? Let's test it out. Let's test it out. Let's do, I don't know why I keep picking. 7 minus 1. And let's do 57 plus 1. So I got a 58 and a 6. Let's add, are you guys seeing that those ones cancel out if I add them together?
Yeah.
Okay. And so I get 64 equals 64, correct?
Well, wait,
It's true, right? You guys seeing that that's true? If I add them together, it's true.
Isn't that obvious though?
Well, okay. There's a reason for this, Mikey.
I know, but it's obvious is what I don't get.
That's good. I think it's all obvious, Mikey. So, like, what's your point, man?
I know, but like,
Everything is obvious.
Okay, so looking at number 1. If we got number 1 yesterday, you would substitute y in for y, right? Okay, but thinking about burgers and dogs, we're going to learn this new method called elimination method. It's going to be an option. What variables look like I could probably get them to cancel?
4 and negative 2. And y.
Well, those aren't variables. 4 and negative 2. I could get x to cancel by multiplying the bottom one by negative 3. But I'm going to suggest this. I'm going to suggest multiplying that whole second one by negative 1. So just follow me. Because as Mikey said, it's obvious. I'm not saying it's obvious. I'm just joking. Okay. If I multiply that whole second one by negative 1, look what I get. Okay. It's the same equation. Right? So watch what happens when I add my two equations together. Y and negative y makes 0. 3x and negative x makes 2x. And 4 and 2 makes
6.
So, since I got something to cancel when I added my two equations, notice, and we know it's true because I proved it's true a moment ago, notice what variable's left.
X.
And I can solve for x. Boom. Boom. Okay? Hey, if your computer's open in class, I need you to shut up because we don't need it for anything. Okay, so here's x equals negative 3. Here's what's cool. Can I find y?
Wait, does negative 3 equal x?
Yeah. Let's go check out what y is. I'm going to plug it in for that one right there. Y equals negative 3 minus 2. So what does y equal?
This is so obvious. I'm so shocked.
So I've got point negative 3, negative 5. There's a lot going on here. It's only the first one. Don't worry if you're like, okay. So let's check it. Negative 3 in for x. Negative 9 plus 4 is negative 5. Cool. Negative 3 in for x. Negative 3 minus 2 is negative 5.
Do you always
Cool.
times it by negative 1?
Not always.
You can if they're the same coefficient.
Or today, I could have multiplied that second one by negative 3, and it would have eliminated the x and left me with a y.
Wait, can we do the second one?
Not yet.
No, because I have a question about number 2, which we're about to do.
We're about to do number 2.
Yeah, I have a question before this.
Yeah, what's your question?
So on this one,
Yeah,
like, would the best thing to do be multiply it by negative 1?
one of them.
Yeah, the top one.
It doesn't matter which one,
No,
actually.
but you always want to multiply 1 by
But
negative
John's saying let's do the top one. Let's try it. It doesn't matter which one because as long as one of those x becomes negative, they'll add to cancel.
So it's negative
So
x.
negative x minus 4y equals negative 13. And then I like to just put one simple line through it because sometimes I want to use it later, but I want to make sure like I'm not using the same line twice. So I'm going to add these two together. X and negative x makes
X.
0.
Oh, yeah, 0.
Negative y and negative 4y,
Equals
negative 5y. And,
Negative.
oh, I didn't write that as negative. I was like, what? 3 and negative 13 is negative 10. Cool. Which means I can solve for y now. So it's just the hot dogs and hamburgers. I get them to have like the same number, so like the difference is only because of the other thing. And I proved it with that 6 minus 3, 6 plus stuff, right? Okay. So once I know y is 2, Joe, I'm not ignoring it. I'm just going to get to it in a second. I can say x minus 2 is 3. And you can plug that y value into either thing. One of them sings to me. It's like, plug in here, it's easier, and then I do that. Okay, let's check my ordered pair. So 5 plus 8 is 13. Cool. And 5 minus 2 is 3.
3, yeah.
Cool. Joe.
So, are you just multiplying it by negative 1 to make it easier? Like, negative.
Yeah. So let me.
Can we do the next one by ourselves?
Yeah. Looking at number 3, you guys seeing those x terms popping? Like we want to get rid of one of them.
Yes.
It doesn't matter which one we want to get rid of. I'm just going to multiply the top one. It won't change the answer. I'm going to multiply everything by negative 1. So I get a negative 3x plus 10y equals negative 14. I like to put a simple line through there in case I want to reference it. I add these together and I get y equal, oh, that's kind of nice, huh?
Yeah.
Y equals 1. And then once I know that y is 1, I'm going to pump that back into one of my equations. Negative 3x plus 10y equals negative 14. Subtract 10 from both sides. Divide everything by negative 3. I get an x value of negative 8, which means my ordered pair is negative 8, 1.
I got it.
That is and remember, when we get our answer, it's the spot where these two lines cross. That's what we're doing.
Can we try 4 in a row?
All right, we're not going to do number 4. We're going to skip to the next page. Now check it out. 4x and negative 4x makes 0. So I have 16y equals 16.
You don't have to do that. You just wanted to cancel out. These already cancel out.
I get a y value of 1.
Wait, 6.
4x plus 9 times 1 equals 5.
Yeah,
Subtract
because 11
9.
plus 5 equals 16.
Negative 4.
This is witchcraft. Yeah, see? This is now.
X is negative 1.
None of this makes sense.
Really, we just want to get something to cancel when we add them together. It works for the same reason that this works. 12 equals 12. It's the same reason. Same reason. Don't write this down. Let me show you how my teacher made me do number 9. My teacher made me do something like minus 2x from both sides, and then have negative 2x minus 4y equals negative 8. And then I had to multiply by negative 1, get 2x plus 4y equals 8. And then I add them together, and that's going to cancel. That's kind of like a lot of work, even though we all can follow, right? We can know how to move things around. And then I was like, what happens if there's another way? Like, if I add the left side, right side together and something cancels, it works. So guys, I discovered this by just seeing if it worked. I've been teaching algebra for something like 6-7 years now. You know, I'm an old man. I took algebra in 8th grade. I never knew this would work until yesterday. You ready for this discovery? Kids in first hour called it snake method. So what I did is, do you guys notice on the left side currently there's a 4y and a negative 4y?
Yeah.
Well, if it's true, if I add my left side, it equals my right side, it should be true no matter where my variables are, because they're all just numbers.
Yeah.
So they call it the snake method because I did something like this to separate my sides. That's just a visual for me. So check it out. If we add the left side together, what do we have? 5x, right? If I add the right side together, and it still eliminates my y term, and I didn't have to do that junk where I made two standard forms multiplied by -1. I just have an equation I can answer now. Now, remember that first step to make that first equation in the standard form? What did I do to both sides?
No idea.
Minus 2x. Look what I'm going to do right now. Whoo! 3x is 12, so x has to be 4. Oh my
I feel
gosh.
bad for the people in any other year.
You don't have to make a standard form. Take that.
Yeah.
I feel bad for
I'm going to call Mrs. Warner tomorrow. So,
That makes sense because
no, there's no difference. I'm adding my two sides together. Something got eliminated, right?
your two sides.
There's a left side of an equation and a right side of an equation. The left side of the equation is on the left side of the equal sign. The right side of the equation is on the right side of the equal sign.
And all make sides are
Currently separated by a squiggle. So, when I add my left side together, I get 5x. When I add my right side together, I get 2x plus 12. Then I have only variable x, which I can solve for. X is 4. Once I know what x is, I can plug this into any equation I
This
want.
makes me think of the hamburgers.
I'm going to choose this one.
This makes me think of the hamburgers problem.
So 4y is 8 minus 8. That means 4y is 0. 0 divided by 4 is 0. So my ordered pair would be 0.
Isaac said, do you determine the left and right side?
I'm fairly certain that this left side, right side thing working out, someone else has done.
You know, you really are.
But if you look at like any notes, you look at any YouTube, they tell you like make them both standard form, get something to cancel. You know me, I hate like rules with math.
You really are.
But this is based on the same concept of what we had been doing when they're both in standard form, right?
You really are.
Add the left side equals right side. So first I call it the snake method because that little squiggle
No,
thing.
let's change
But
it to
you can do whatever you want. Let's try out this left side versus right side. So when I was in school, I had to get them both in standard form. But let's check. Are you guys seeing the left side has that the y's that cancel?
Oh my god. Yeah.
So I get 2x equals 2x, which means
Infinite.
infinite answers.
Okay, that's what I'm for. Technically,
Infinite answers. But if I did like minus 2x to both sides, right? I want you guys to try this with number 8. But it works for number 8, but let me caution you with something. On number 8, are my y's on the same side? No, but there's a thing called the commutative property, which means like 2 plus 2 is 4, so 4 is 2 plus 2, right? So let me just set you up to try this method on something like 8. I would rewrite my first equation as 3y plus 11 equals x. It's the same equation, and then I would add it together, okay? So try it out. Let's take a look at number 8. So I'm eyeing left side, right side here. And are you guys noticing my y's are canceling? Okay, so left side would be 2x plus 11. Right side would be x plus 16. We good? I subtract x from both sides. X plus 11 is 16, which means x must be 5.
That's what I got.
Once I know x is 5, you can put it into any equation you want. Solve for y. So 5, -2 would be the point in which these two lines cross. Joe!